All right, hi ho math students, it's Mr. O, and it's Unit 5, Lesson 5, and this time we're going to deal with word problems with systems of equations. So that's our job, our objective, to solve word problems. We're going to write them, we're going to write and solve, and see what we come up with, see where they cross, see what we come up with, all right? That's our goal. Here we go. All right, in exercise 1, we basically have a case where Jonathan has 9 bills, okay, it says, in his wallet. And they're either $5 bills or they are $10 bills. So that's something you want to keep in mind, either $5 bills here or $10 bills, okay? So the first thing we're supposed to do in part A is fill out the table and see what's going on in the dependence between the two variables. So obviously if he has 0 $5 bills and he's got to have a total of 9 bills, he must have 9 $10 bills. And you guys know that 9 $10 bills means 9 times 10, he's got 90 bucks in his pocket then at that point. If he has one $5 bill, 1 plus, there must be 8 $10 bills. Well, you get a $5 from the 1 plus 8 tens is 80. So 80 plus 5 is $85 in his pocket. If he has two $5 bills, he should then have 7 here. And that will give him $10 from the two $5 bills plus 70, that's 80. And if you see the pattern going here, you should be able to hit this real quick and go ahead of me. If there's 3 there, you know the pattern's 6 because we keep going down by 1 in order here. And you should know that the grand total on that one is going to be $75, okay? So that's filling out the table. You should be able to do that at any point, not a big deal. All right, now, part B, it says, if F represents the number of, we got here, $5 bills, and T represents the number of $10 bills, what in the world does this expression calculate? Well, it's pretty straightforward. If you got 5 times every, whatever the number of $5 bills is, times $5, that's the amount of money you get for the $5 bills. And $10 times the number of $10 bills is the amount there. So this will be his total money. So it's total amount of money. Okay, pretty straightforward. That's what that represents. Okay, now we got to get to the big baby. If Jonathan has a total of $55, it says here, okay, and he sets up a system of equations with the F and the T, how many of each dollar bill for $5 and $10 does he have? Solve the system. And remember that he has a total of $9 bills. So if I'm going to sit there, first of all, I know that his F plus his T, the number of $5 bills plus the number of $10 bills, has to equal, going back from the original, way up at the top here. He said he had 9 bills. So there's one equation. The second equation is the one I kind of just set up. There's $5 times each of the $5 bills he has, plus $10 times each of the $10 bills he has, and the grand total they just told you here has to be 55. So there's my 2 sets of equations, okay? Now we got to solve this thing. Well, I'm taking a look at it, and depending what way you want to go, I like elimination. It's not set up for substitution and stuff like that. So I'm going to basically multiply this whole thing right here by, I want to get that 5 right there. So if I do that, I get a 5F also, but the problem is I want the opposite sign. So I'm going to use that method of elimination. And so that thing turns into, if I put it right below it, it's going to be a negative 5F, a negative 5T, and then it equals a negative 45. Okay? Now, I know it's space-wise, I'm going to take these two and put them together now. If I go and add, the F's cancel. 10T minus 5T is 5T. And 55 minus 45 is 10. If I divide by 5 real quick, and we'll run out of space here, the number of $10 bills is equal to 2. So my T is 2. Then I'd go back to the original here. F plus T equals 9. That's the easier of the 2 equations. We now know that T is 2, so F plus 2 equals 9. We're substituting it back in. And then you move the 2 to the other side, and bingo, your F turns out to be equal to 7. Sure enough, 2 plus 7 equals 9 bills. If I take 2 tens, that's $20. And 7 fives is 35. Well, 20 plus 35 is 55. I know that it works. Okay? We'll keep moving on with this problem. All right, and the last part of this question, number 1, basically says, let's say we were told that Jonathan here has 7 bills now. So we know that he has 7 bills. That's changed. And they were all 5s and 20s this time, so that's also a change. And he has a total of $120. Set up an equation and do it. Well, I know I have 7 bills. I'm going to still let x equal the number of 5s. And I'm going to let, well, let's see here. We let f last time, so we'll keep it f. And we're going to let t equal the number of 20s. Instead of 10s, 20 begins with a t too, so keep it that way. So this time we got 2 equations. I would say the f for the 5s plus the 20s, which is t, has to equal, they said, 7 bills. So there's your 1 equation. We know it's 5 times every $5 bill plus 20 times every $20 bill, and that has to equal the grand total we said of $120. So my system didn't change that much. Looks like the same process again. Now, if you want to change some other way, you can. I would once again take the first one, and I'd multiply by a -5. So this time I think I'll come over here and we'll do this. So I got a -5f plus a -5t, or you could just put -5t, equals, because you have to distribute all the way, -35. And I'm going to rewrite the other one. Last time I shortcutted it. Plus 20t equals 120. If I add the two together, bingo, there go my 5s again. This time I got 15 t's. This time the t is 20, so equals, and if I take 35 and I take it off of 120, you will end up getting down to, what do we get here, 90, 85. And then our job from there is divide by 15. Divide by 15. And t is going to end up being something like 5.6 repeating on the calculator. All right. So we've got an issue. Can you have 5.6 repeating $20 bills right here? No, there's a problem. So somehow the question is one of those trick questions again. So somehow you have some false info. Okay, something went wrong somewhere. Maybe the $120, maybe there's more than 7 bills. I'm not sure what happened. But you can't have partial bills. Can't have fractional bills. Okay? So just keep that in mind as your answer here. We actually don't have a nice solid answer on this problem. So error, you might have to justify. There's your work to justify. Okay. We're going to go on to another question now. Don't be worried when you get something like this. That could happen. All right, in example 2, it says Sam basically has a concession stand, goes to the concession stand, and she buys 3 pretzels and 4 sodas and pays a total of $11.25. Then her friend Raza goes and buys 5 pretzels and 2 sodas and pays $8.25. They want to know, first of all, could the cost of $1.75 each for the pretzel and $1.50 for the soda? And then we take a look at them. Well, she brought 3 pretzels, so you do 3 times the pretzels are $1.75. And she bought 4 sodas, so 4 times $1.50. And the question is, does that thing equal the $11.25? Well, if you pause and do the math, or just do it, you will see that $11.25 equals $11.25. So we're okay on that one, no problem. However, when Raz goes and does it, she bought 5 pretzels, so that's 5 times $1.75. Which is almost $10 right there. Plus, she bought 2 sodas at $1.50 each. And they want to know, is that thing equal to $8.25? And bottom line is, I know just from the pretzels we're already over. So if you do the math, it actually comes out to be, I believe, 11.75. That clearly is not the same thing as $8.25. So no, the bottom line on this one is no, the pretzels and that soda couldn't have cost those prices. Okay, you got proof that it didn't work there. Well, now in part B it says letting x equal the unit price or cost of a pretzel, and y the unit price for cost of soda. Write a system of equations. Well, you just did it a second ago. Okay, change color here. We'll go with this. But bottom line is, instead of putting in $1.75, we're calling x pretzels instead of $1.75. So it's 3 times x plus 4 sodas. So 4 times y has to equal 11.25. There's one equation right there. The other one was for her friend, Raza, and she bought 5 pretzels plus 2 sodas, and that has to equal $8.25. And bingo, you've written the equations. You just did it a moment ago, and you didn't even recognize it. It's that simple. All right, we're going to go on to part C and actually solve these now. All right, in part C, you can tell, definitely not set up for substitution or graphing, so we're going to try elimination. You could do the old one where you do times both. I'm going to multiply just this line because I'm taking a look at the y's here. Okay, 3 and 5s, they don't work together too well, but you can use that method if you want the double elimination. I'm going to take this. If I double the 2y, I actually get 4y then, so I want to make that a minus 2, though. I want the opposite sign. So if I take a look at this, I rewrite 3x plus 4y equaling 1125. And if I multiply and distribute through, I get a negative 10x, a minus 4y equals a negative 1650. Okay, trying to write this the best I can. The y's will cancel. I will get a negative 7x here out of that, and that equals a negative $5.25. So then when I divide by a negative 7 into a negative $5.25, I actually get that x turns out to be 75 cents. So that's going to be your cost of your pretzel. So here's part of our answer. But we're not done. We also want to figure out the other part, how much the cost is for the sodas. So you got to take one of your equations. I'm going to take 3 times x, so 3 times 75, plus 4 y's has to equal 1125. And if I do this, you get $1.50, I get $2.25, plus 4y equals 1125. Move your 225 over and subtract it. So then I get 4y equals, take 25 cents off 11, it's $9. And if I divide by 4 here, so if I divide both sides by 4, I actually get $2.25 for the cost of a soda. So those are my two prices. Real world problem we just solved by setting up a system of equations. Alright, in this last problem, exercise 3, I'm going to get this started for you. But basically, you got a rectangle where they tell you the perimeter is 204, and I put that right here inside and drew a little picture. It also tells you a piece about the length being 6 feet longer than twice the width. Let L equal what stands for the length and W for the width. Write a system equation. Well, the first thing you probably should remember is that the old perimeter formula means to add up the whole outside. So you've got a W plus an L plus a W plus an L, and some of you know that formula to be equal to 2L, 2 W's plus 2 L's, either way. Okay? But we can replace the P because we now know it's 204. So our one formula is going to be 204 equals 2L plus 2W, or vice versa, okay? And that's our one. So there's one of our equations, okay? The other one says that the length is 6, back up here again, is 6 feet longer than the width. So I have that the length is equal to 6 feet more than twice the width. So that more than means to add, once again, twice the width. So there's my other equation. So I want you to finish this one off, and we're going to check it in class tomorrow. And take this, it set itself up nicely for substitution, and take it and plug it in right here. So you should be doing this. 204, get you going on it, equals 2 times, in parentheses, 6 plus 2W, and then plus 2W on the end. So please finish this one, and we'll check to see what you got your answers for your width and your length tomorrow in class. And write a nice WSQ. All right? Have a good evening.